Hello, this is Jasmine from Tutors 11 Plus. Today we'll be looking at prime factors and factor trees. Prime factors are numbers which are factors as well as prime numbers. So all of the factors you find must be prime numbers. If we look at 10 as an example, the factors of 10 are 1, 2, 5 and 10. However, only the numbers 2 and 5 are prime factors, as they are also prime numbers. We all know from the previous video on prime numbers that the number 1 is not a prime number and 10 is not a prime number. Now, to find the prime factors of a number, we can use a factor tree. This is especially useful when we're looking at larger numbers. A factor tree is where you write a number as the product of its prime factors. Now remember, product is when you multiply. So for example, the product of 2 and 3 is 6. And now we will look at examples together, but you'll see that the factor tree will continue to grow until all of the factors are prime numbers. Let's take a look at some examples. Write 36 as a product of its prime factors. This can be done in a few different ways. Let's start with the first one. 36. What times what equals 36? As it's an even number, we can easily say 2 multiplied by 18 is 36. Now, is 2 a prime number? Yes, it is. So we actually stop this branch here. Let's circle this. It's very important to note that the number 1 is not used within any factor tree, as it is not a prime number. We know that the first prime number is 2. If you need a recap on this, go back to our video on prime numbers. Okay, so 18 can be further broken down into 2 times 9. As we know, 2 is a prime number, so that branch stops there. However, 9 is not. This can be further broken down into 3 times 3. And 3 is a prime number, so that stops there. Another way, another factor tree we could use for 36 is 4 times by 9. Now 4 can be broken down into 2 times 2. Circle these because they're both prime numbers. And 9 can be broken down into 3 times by 3. Again, prime numbers. Circle these, and that's where it ends. One more way we can look at this. 6 times by 6. 2 times by 3. Both 2 and 3 are prime numbers. And again, 2 times by 3. So we circle these. And now we have all of the prime factors circled. So the answer for writing 36 as a product of its prime factors, we would write 36 is equal to 2 times by 2 times by 3 times by 3. Now you can see very clearly here that it doesn't matter which way you break down 36, which factor tree you use, you end up with the same answer every time. 2 times 2 times 3 times 3, 2 times 2 times 3 times 3. Now, you don't have to write this in order. However, I always recommend you do so because it's easier for you to see and follow. It also allows you to write the answer like this. 2 squared multiplied by 3 squared. You'll often find questions ask you for this method. Let's look at one more example. Let's say we wanted to look at the prime factors of 72. We want to see 72 written as a product of its prime factors. Let's see. What times what is 72? 6 times by 12. Are either of these a prime number? No. We continue. 6 is made up of 2 times by 3. Now, we know that 2 is a prime number and so is 3. So this ends here. However, 12 can be further broken down into 3 times by 4. 3 is a prime number, so I'm going to circle that. 4, however, is not. This can be broken down further into 2 times by 2. 2 is a prime number, and now we're finished. So, writing 72 as a product of its prime factors, we would say 2 times by 3 times by 3 times by 2 times by 2. It's a very good idea to cross them off as you go along to make sure you haven't missed any out. I would now rearrange this so that the 2's are together and then the 3's are together. So 2 times by 2 times by 2 times by 3 times by 3. I could then rewrite this as 2 cubed multiplied by 3 squared. And that is our video on prime factors and factor trees. These can be quite difficult to master, so it's very important that you know your times table very well, and it's also very important for you to practice as much as you can. Remember, the more you practice, the better you'll get. Thank you.